All right, everybody. So in this tutorial, we're going to look at using N particles to make something sort of disappear in dust. And this will give us the ability to deal with N particles, surface emission, fields, turbulence, as well as working with some maps and, of course, some rendering. So I'm going to try to do this as quickly as possible, so bear with me. So here we have like a pretty nice little typical scene, a little skull, and we're going to make it as if this is a very ancient skull that gets blown away into dust. So we're going to start with, I've got a bunch of things set up here that we're going to deal with, and I'll walk you through those first. So I kind of did a little bit of work ahead of time, and I've got, of course, a textured skull here, and if we render it, you can see that it's got a little butt map here. Things look nice. So I'm working in V-Ray, which has certain render parameters that you might have to translate based on whatever you're working in. But for this case, it's a pretty nice option for us. So just to go over what I've set up so far, I have my skull, and I've got some backdrop geometry that I've put on a layer that's set to reference for now. I have a light and a camera, and my camera is animated here. So what we're going to do, the other things I want to show you are sort of the maps that I've pre-built for this animation to happen. The concept here is that we'll have a line traveling down the skull, which will be the point at which this skull will turn into dust and blow away, and then it will disappear behind that. So we're going to do this in a really kind of cheap way, but it is effective. And I've got a couple textures here to show you. So I have a line of emission. So if I drop that on the sphere, on the skull here, and we wipe through it, you can see that this is really just an image sequence that I created in After Effects that just has a line going through. And if we pop over to After Effects, hopefully you can see this. Let me resize this. Here we are. It's just a simple noisy line that travels down the UV coordinates here. And if I turn on the other adjustment layers, you can see that I also have what will be our opacity map, white being fully opaque and black being fully transparent. And that'll travel after. That'll travel alongside that. So if we switch over here, this is going to be our emission line, and this is going to be our opacity line here. Okay, so if we were just to implement this as it is now, I do have this texture map with the skull, and if we take a look at this one, it's the same. Whoop, sorry here. Where did you go? Skull shader, skull vanish. So I have an identical map here, which has the opacity map loaded into the opacity map of this V-Ray material, same texture. And if I pop it onto here, and we roll forward a little bit, you'll see that this is how it gets displayed in my display. And if I render this out, you'll see that it's just cutting it off here. So what we'll be doing is we'll be following along and generating particles along this map as well. So just as a quick note, obviously this skull was set up with a UV map that's just a quick cylindrical map. Now, if you want to have something more complex than this for your other texturing, that's fine. You can actually create a second UV set that you can put this UV layout onto, and I can show you how to set that once we attach this to the emitter. Okay, so this is our skull vanishing. What I'm going to do is start off by generating our particles, right? So the first thing we want to do is generate particles from the skull and start from there, right? So we're going to select the skull, And we'll go to our effects menu here and go to End Particles, Emit from Object. And we're going to choose the option box here to make sure we know where we're at. Most likely, your option box will look like this, where we have the emitter type as Omni, and this rate being right here. So what we don't want is we don't want Omni, because that will emit from every single vertex in the model. And while this model has quite a few, that's not something we want. We want to do a surface emission, which allows us to emit over the entire surface at one time, using the UV coordinates as how that works, right? So it's important to have like a UV layout that's going to work for you. And I'll show you why in just a moment here. So we can start off with 100 particles per second. And notice that it is per second, not per frame. And then speed, we actually want to be 0, because what we're going to do is emit it, and we're just going to let it blow away. And our normal speed also 0, right? So we'll go ahead and create that. Okay. So when I hit play now, what we should see is particles generating and doing what they do there. Now once again, let's see, let's hide our skull here for a moment. We can see the particles generating on the surface of the skull, and they're just going to fall. So I'm just hiding the skull in this case, because there's no point in having it get in the way, because we kind of want to see what our particles are doing. And it's working as if the skull is there. So you can see that they fall right away, and that might be something that we want to deal with, but for now, I think it's just going to be best for us to deal with trying to visualize how these particles are going to be working. So as I let this emit, I think it's going to be easier for me to just check these out while they're not falling. So I'm going to go ahead and go to our attributes editor with our particles selected, and I'm going to, let's see, I'm going to close most of these up so we can see everything. So I'm going to go to our dynamic properties and turn on ignore solver gravity. Right? We might go back and we might turn that back off. But for now, we just want to see how many particles we're getting. Right? So there they are building up on our skull. Not too many, really. Right? So we can always come into our emitter and bump this up to something more exciting like 5,000. That's better. Now we can see our skull. So I think what would be nice in this case right now is to actually try to get these to grab the color of the skull, right? So if we remember that our skull has these two textures. One of them is one that makes it disappear, and one of them is this weathered texture right here. So what I'm going to do is head over to our emitter, which is located under our skull geometry. And we're going to scroll down to the bottom, and we have a particle color emission attribute here. So we're going to drag this onto there, and now if we select inherit color, we'll get an error down here, a warning. Right? And it says that our particle does not have this attribute, this RGB PP, right? And the PP attribute is a per particle attribute, and RGB obviously should be for color. So when we play it, we don't get anything. So we have the same color that we had before, so let's go and fix that. So we're going to head back to our particle tab, and we're going to scroll down until we see something called per particle attributes. And what we want to do is we can look through this list and we can see that, yes, indeed, RGBPP is not included here. We're going to scroll this down and we're going to see color right here. We're going to click that and you see an add per particle attribute, right? And basically what Maya doesn't want to do is keep track of a ton of attributes right from the start. We want to sort of add these in as we need them, right? So here we're going to add in this per particle attribute. And what that adds is this RGBPP, which will now, when we turn this on, we won't get the error down here. So we'll roll back and we'll play it. And we can see that we get different colors here. And if we were to let this totally fill in, we would see that it would be inheriting all the colors from the texture map. And that's great news for us because now each particle will come off of this skull and it will pull that color along with it. So here's also where you could change which UV set that these are dealing with. And you want to kind of be able to work in a UV set that you can pull the particle color with, or use this different map. Although, if I'm remembering correctly, this might just refer to texture rate. But if you did have a different UV set, you could also adjust it here. So here we have our particles now, and they're forming on the skull, and that looks pretty good. The next thing we want to do is deal with this emission rate, right? We want to have that stripe wiping down and emitting particles along the way so that we can blow them away. So that's pretty straightforward as well. Once again, we come up here, we have our textures. I have this emission map, which is just a line that wipes down, and you see it's an image sequence. I turn on image interactive sequence caching. That allows for better playback. I also typically turn off my filter type so that it doesn't get filtered any more than it needs to. So once again, back to the emitter. Down here, texture rate, and I'm just going to drag that onto there. And right away, you can see that we need to actually enable it, right? If we just let it play, nothing happens. So I'm going to go ahead and enable it. And if you happen to go with the inverse, with the texture rate, it's always the bright colors do the emission, the bright value, and then the dark value does the lack of emission. And in between values do lower emission. So you can invert that if you need it to be inverted. So if we do this now and we let it play, you can see that we get this progression now, and that's really good news for us. Now, what you'll notice is that we have far fewer particles. So the way that we have to think about surface emission is not that it looks for the white areas in the map and then emits. It actually does something a little different. If we go to Photoshop, this would be our UV space. So you can imagine our geometry laid out on here in a way that we can travel from top to bottom of our geometry. And what's happening when we give it a texture rate, or when we give it an emission rate, is that it puts right now 5,000 particles per second on here. And so it distributes them across the entire UV surface. And then it cuts out the sections that have the map, that have the geometry on it. And then it further cuts them out by our emission map, right, which would be here. And if we just multiply it, we can see that we get far fewer particles. So if we start with 5,000 particles per second, by the time we cut it down, we might only be emitting a couple hundred particles per second. So we do need to increase our rate value quite a bit to deal with that. So what I'll do is I'll head back to my emitter, and I'll put in a much larger number. So this one is kind of something you have to figure out. I'm just going up by 2 powers of 10 here to see what I get, and I'm getting something a lot more dense. So I'm going to start with that because it looks like enough particles that I can kind of work with here. Things are playing back all right, especially with the recording, and we can deal with that. Okay, so at this stage, you can kind of go either way. You can start figuring out how your fields work, or you can start figuring out the look of the particles, things like that. I'm going to start with my field motion while I'm still dealing with sort of a lower number of point particles. All right. So what I really want to have this do is almost like it's blowing away as it's disintegrating. So I'm going to select my particles, and to attach a field to it, the easiest way is to just go up to our fields and select the field while the particles are selected. That does an automatic connection, right? So I could choose any one of these, and you could start with air, and you could add some turbulence. But one of the ones that I really like is this volume axis field, because it gives me a few options all in one. So I'm going to go ahead and choose that. And you'll see that if we go to our wireframe view that we have the volume axis field down here. All right, and I can go ahead and lift that up. And I'm going to grow this. All right, so everything happens within a volume axis field, right? So you kind of need to adjust the size of this. I'm going to switch to my standard perspective view so we can see with a static camera. And if I just let this go, what you'll see is that they get pushed away from the center, right? You can see the arrows and they get pushed away from the center. We get a cool like egghead skull, which I kind of like a lot, but that's not what we're dealing with right now. What I like to do is blow it this direction. So I'm going to wind back and I'm going to go through the settings of my volume axis field to see what I can sort of achieve here. So I'm going to go and take a look, and we've got two major components to this, which is our volume axis attributes, our speed attributes, and our speed control attributes. And you can choose different shapes in here. You know, whatever's going to work out for what you want. We have cylinders, cones, cubes, and even curves you can attach these to, which is really great. So we're going to deal with a cube here. And notice, you know, always look at what you can do, like trap inside. There's a trap radius. So there's some really interesting stuff. Right now, we can see that we have this away from center that has a value of 1. And these are all sort of multipliers of the magnitude up here. So away from center is 1. And you can see that if I reduce it, we get a little diminishing value there. So I can pop this to 0. I don't want that. We have a long axis, which goes that way. Okay, goes up. So I could just simply rotate the cube, but I also have this directional speed. If I turn that up, you can see that I get an arrow in this direction. And I can change that direction to whatever I want it to be. But that actually works out right down the x-axis, 1 for the x-axis. We also have this rotational thing. You can do a ton with this. So let's put this up here, directional speed 1, and let's look at that. All right, so it looks like we're getting a little bit of speed. You know, we're kind of getting along what we want, but we definitely want this to be moving much faster. And this is where the back and forth begins. What I want to do is, I definitely probably want to increase this magnitude, but the first thing I want to do is think about what is the mass of this particle? How heavy are they? How easy are they to move? So if I go back to my particle shape and do this, and I start looking at my options, in my dynamic properties, just where we found this ignore gravity, I also have a mass scale here. And right now our maximum is 1. And there's a randomization value here. What I'm going to do is lower my maximum. Actually, just lower my value here to 0.5. Right? So it's now half as heavy as it was, and we should see a lot more movement here. It's going to get moving a little bit more. Well, not as much as I would hope there. So let's lower this even further. And actually what I'm realizing is that our input here is even off. So that's not even going to help us out. What I want to do is actually put this onto a randomized ID. So it's going to jump all over this ramp here and then pick a value and assign it. So if you see what I'll do is I'll make this high and just above 0. And you'll see a great difference between what will happen here. So some are going to pull off really fast and stream away, and some are going to lag behind. And then they're going to get outside this field and they're going to stop accelerating. They're just going to hold on to the velocity that they've got. So that's really interesting. And I want to lower this much more. I want these to be fairly lightweight. And we're going to see them pull away. So we definitely have a better motion here. I'm going to definitely need to make my field bigger to encompass more of this space. And what's nice is I know I'm just going to blow them this way, so I'm just going to move it down. So we have sort of this look here. I'll go even a little larger. Don't know how far we're going to end up blowing them here. So finally we can go back to our field and we can start adjusting this. Like, let's increase our magnitude quite a bit. Let's start with 10 and see what that gives us. And it's just a quick little test here until well, that's pretty good. Maybe even a little bit more. 15. Great. All right, so we've got these blowing away right now. And it's looking pretty good. You can see the colors are still good. Next thing we want to do is add some turbulence into this. And we can do this right in here. It's also one of the qualities of the volume axis field that's nice, is you can just add some base turbulence here. And it really is our baseline turbulence. What's our big motion that we want to get out of this off the bat? So we have this very linear action here. So I'm going to go ahead and turn this turbulence up. And now you have to remember that this is going to be very sensitive. So even if I put this at 0.5, you'll see quite a difference in what happens as it pulls away. And that's just pretty extreme for me, although it looks really cool. So I'm going to bring this down to 0.2 and see if that's all right. So we get a little bit of that turbulent wind going in there, which is pretty nice. And then the other options we have here are turbulent speed, which is how fast the shape of this evolves. I'm going to increase that so we get a little bit more variation over time. Our frequency is how big this wave is, right? So higher numbers make these waves smaller. Lower numbers make them larger. And finally, we have this detail, which adds small little turbulent noise to the bigger stuff anyway. So we get something more like this, right? So that is pretty extreme. What I'm going to do is turn my frequency up a little bit so we have a little bit more noise in there. All right, that's looking pretty cool. All right, so we're going to start with that. Now I might want to see what turning on gravity is going to make this feel like again. So I'm going to come up here because gravity is one of those things that people really sort of attune to a little bit. We've got a bunch of forces working on here now that pulls that along, which looks pretty good. But they're passing through all of my geometry here. So I'm going to go ahead and start activating my geometry as a collider. So I'm going to go and select these two items, and I'm going to go and create a passive collider. All right, so now we've got two passive colliders. Let's see what that does. You're going to come in. We'll get some impacts down here. That's looking pretty good. It's dragging along the ground. I think what I'd like to do is maybe increase the friction a little bit. And I'm going to add some bounce. Just because I think this would, little particles of sand will bounce just a touch when they hit a hard surface. And that little extra action might feel pretty good. And if we get a lot of slowdown when they hit here, we'll get some more differentiation. So there is everything blowing away. And that looks pretty good. Pretty good. So I think what I'm going to do is add one more thing in here. And you can see that everything is just really spreading out. And part of the reason is because we don't have any wind resistance going on. Instead of adding wind resistance, what we can do is add this conserve value into our particles. Right? Again, under dynamic properties, we can take this conserve value and just drop it down a little bit. And this will basically take the speed that it's traveling, the velocity of traveling, and multiply it by this number. So we start to get things that bunch up a little bit. And we'll get to see the lines of turbulence a little bit more. We can get a little bit more gathering there. And what we might have to do is increase our wind speed a little bit, although maybe not. We're getting pretty good distance here. Okay. that's not bad. I think one more round, something I just always like to add a little extra turbulence into these things. Not much, but I'm going to take a turbulence field. I'm going to add it into the system with the particles selected. And now I've got this one more field, and I'm going to move it through the space in the direction that the particles are moving. So I'm going to go ahead and key that. Move forward to the end of my animation, and I know I'm making it down here, so I'm going to move it down here. I'm going to make sure that that action is linear. Okay. And we'll play it back. Now we probably won't see much here because by default Maya loves to put this attenuation at 0. So I'm going to go ahead and lower this, increase my magnitude a bit, and lower my frequency. So this is going to be like a big wave that comes through and just pushes these things around a little bit more in contrast to what we already have going on. So you can see the difference of the motion that we have there. And it's going to be this sort of standing wave that moves through because this is moving sort of with the particles. All right. Great. So let's start with that. So there we have our particles moving, right? We have two fields, gravity, particles are being emitted, and now the next thing we want to do is think about the look of these particles. So let's, first of all, the first thing we want to do is we want to turn these into something that's a little bit more controllable to render, which is going to be our spheres. Right? This is going to be better for us because if we ever do a camera move that involves being in amongst it, we'll get a lot more depth perception than we will with the points. And we can make these as small as points anyway. So we can run up here, once we've activated that to spheres, which is under shading, we can come up to our top and change our particle size. And our particle size we're going to bring way down. Well, that's probably way too far down. For the purpose of this video, I'm going to start, I think, at 0.08, which I think we can still see in the playback the video. And we'll randomize our size quite a bit. All right. So that is that. Now, if I were to render this right now, and I can, if I render this, what we'll see is that these particles have, oops, I wanted to turn that on in a moment. Let me turn this off for now. Here we go. So you'll see that the particles are black. And that's obviously not what we want. All right. And the problem with this is that we're not passing the right information to V-Ray itself. Right. So I'm going to stop this. And let's go back to our particles. And for many rendering engines, V-Ray and Mental Ray, and I'm not sure about Arnold yet, but probably, you'll need to attach some attributes to this so that the renderer can read it. So we're going to go to Attributes, V-Ray, and choose Per Particle Attribute Export. And that's going to, that's under our particle shape. That's going to add something to the very bottom here that we can go down and check. And one of these that we want to export is RGB. So let's go ahead and look at our Hypershade. And we're going to want to create a material for our particles. Right? So another standard V-Ray material. Here we are, V-Ray material. Let's just graph that out. And in the color attribute, we want to add something that will get the particle's color. And if we scroll, if we go to our utilities and we scroll down, we'll find the very useful particle sampler node. Let's Let's see where that put that, way down here, of course. So our particle sampler node, again, by default, thanks Maya, is that it doesn't have the most useful information unless we expand this, and we can find our RGBPP value down here. And that's exactly what we want to be attaching to our color value. So our color value is way up there. And so we can go RGBPP to color. And there's a lot of things you can attach in here, just out of curiosity even. Velocity and acceleration, age, you can attach them to any of these and you'll get some really interesting results. So once we've attached our RGBPP to our color, that means that every time a ray hits a particle, it will ask it what color it is and assign that color to the shader. The last thing we have to do is assign our shader to our particles. So let's do that. And then we'll render again. And now we can see our particles have attached that value to themselves. So that is all super great news. We can stop this. We can go back, switch to our camera, and we'll check it out early on. And that looks pretty good. I mean, our particles are a little large for this, so I'm going to make them smaller. And in addition, what I'm going to do is it's time to bring our skull back and see how that's looking. So let's re-render that. So here you can see that's going to be pulling our color values from our skull. And it's going to start to look a little bit more effective when things are smaller. So we can grab our particles here, go up top. I'm going to make these guys a little smaller, like 0.03, which should be pretty small in our viewport. And you can see that they're very tiny in here. And now we have one last thing to do, which is to greatly increase the number of particles that we're emitting. I'm going to go to my emitter, and I'm going to add another 0 in here just to see if that's enough. And we're going to be generating a lot of particles at this point. But it may not even be enough particles. So let's let this pull out for a little bit. You can see how those follow along with the invisibility of the skull, and we'll render that. That's not looking too bad. And finally, what we want to do is we want to make sure that we have motion blur turned on for these particles. That's going to be a huge add to any particle effect, because we will know the action of the motion. If we don't have motion blur turned on, then a particle can move from one place to another, and it will look like a noisy jumble, but we won't know which direction they're really traveling. So we'll head over to, of course, our V-Ray settings, and we'll switch on motion blur. And we will render that out. And you should see a big difference in there. Now we can see that arcing motion, the directional action that's happening. Some more samples here would probably be good, and I think I'm motion blurring per frame. So there's a couple of settings to go through. But one last thing we can do, that we need to do before we render, is let's stop this, is we need to run our caching. So I'm going to save this file out, continue, and I'm going to go up to our ncache with our particles selected. And I'm going to create a new cache for this n object. And if we look at the settings, there's a bunch of things we can check. We have the name of the directory that it's getting cached to, the particle names that it's getting cached to, how many frames you want to evaluate, and all of these things will depend on your simulation. But when you're done selecting those, you hit create. And what you'll see is it'll run through the simulation, and it's going to be writing these files to disk. And at the end of it, you'll be able to scrub your simulation back and forth, pick some interesting frames to render, and to check, to, of course, test all your settings. And if you need to go back and alter some of these settings, you just need to delete this cache and recache it. Any settings that you adjust to your simulation while you still have a cache are not going to be shown. So I'm just going to let this run out for a little bit here. I'm trying to think if there's anything else we need to talk about. This is just obviously one version of this effect. These techniques can be used for anything. You can use your particle colors for showing anything that you want to show. You can use these maps. We could have used this map to do another round of emission to make this look like it was burning away, and this was the ash flying away or embers flying away. This skull could have been animated. It could have been dropping, falling through the air and dissolving through the air. So the big takeaways here are just keeping that motion that you want and then adding the levels of turbulence into it and making sure that things are going to render that the way you want them to render. So I just want to let this cache out. We're having quite a few particles. And one thing I didn't do is I didn't set a lifetime to these particles so they don't die off, which means that they continue existence well beyond what they need here. And maybe once the skull is completely gone, I will stop this from caching. You can always actually stop and then continue caching if we look at our cache options up here. If it will let me, which it won't because it's too busy, you'll see that there's a resume cache, delete cache. You can actually do multiple caches and blend between them, which is very handy when you get to cloth simulations. And you can also do multiple takes and save out each cache, and then you can review them and decide which one is the best for your story and for the effect that you want to be achieving. Right, so here we have nice dragging along the floor. This looks all pretty good. I think what I'll do is once I finish this up, I'll render out the full animation with some global illumination and see how that all looks at the end of it, at the end of the day. So you can see that Maya is running a little slow. This is partially because Maya's ability to handle large numbers of particles is not the best. It doesn't hold a candle to a tool like Houdini, although it is better than Nuke's particles in terms of how many it can handle. And I know that this video is long, so thank you for sticking with me, and just let this solve out for the next few frames. I'd like it to get this last little peel off of here before I do anything. While we're doing this, I can show you sort of my approach in After Effects for creating these lines. And you can do this kind of thing in any tool. What I had here was a simple fractal noise, and I have a black solid with a beam here. Let me see if I can switch this to normal. There it is. There's our beam coming down. That's why. A bit smaller there. So I used a beam effect that gives me just a straight line that's gradiated, and I put it on top of the noise field and switched this to linear light, and that gives us this noisy looking action that travels down, and then I just inverted that here and followed it with another solid to do my opacity map, right? And then brought those in as our maps that we needed. So back to Maya, if it will let me. Where are you? And we're just at the end here. And we'll do a final check on the particle count. Now I have, I'm recording the video and I've got an iMac here at home, so it's not the fastest, beefiest machine, but it is not dissimilar to how Maya's dealings with particles are. Okay, 19,120. And there we go. All right, so our final particle count here, and if we just check our attribute editor, where are you? At the top, there's a count. And we can see that we've got only 700,000 particles here. So I know that my machine can do several million in Houdini without too much of a stress. But now you can see I can click around and pick any point, which is quite nice. So we can kind of see midway what things are looking like. And if I switch on GI, it'll give us a nicer look when we render. So that's that. All right, so what I'll do is once this video is saved and starting its post, I will start this render out so you can see sort of the final result of this as well. And I'll post that up too. All right, so that is a simple vanishing act with particles and maps and surface emission, and I hope that helps you when you're figuring out what to do with your own particles. All right, good luck.